A conical tank with vertex down is 8 meters in diameter and 12 meters deep. Water flows into the tank at 10 meters cubed per minute. Find the rate of change of the depth of the water at the instant when the water is 6 meters deep. So the situation looks like this. There is a cone and it is given what, 8 meters in diameter, so radius is 4 and 12 meters deep, so height is 12. And at some moment of time water is at some level, for example like this, and there will be some radius r and some height h. And what do we need? We need rate of change of the depth, so we need dh over dt. Rate of change is with respect to time, how how quickly does depth change. So it's required, and what is given? 10 meters cubed per minute. It's rate of change of what? Of meters cubed is unit of what? Of volume. So it is given dV over dt, rate of change, the volume. And if it's increasing, it's plus, decreasing minus, so it's actually plus 10 meters cubed per minute. And as usual, we need some formula to relate all parameters, and since it's about what? It's about volume over cone, so we need the formula. Volume over cone, 1/3 pi radius squared and height. Notice that we write this formula for arbitrary, for some intermediate, or not for this 4 and 12, because it's at any moment of time. It's as a function with time. And then, as usual, we need to differentiate, but we can see that there are two functions. Radius changes and height also changes. You cannot differentiate v only. You cannot differentiate only h and consider r as a constant, because it's also a variable. But there will arise, there will dr over dt arise here, and a rate of change of the radius is not given, it is not required. And we should get rid of this. And how to do that? We need some equation to relate radius and h, to substitute some expression for radius, and definitely we need it to be in terms of h. How to do that? If we consider this cone, we can see that if we consider this angle, for example theta, and definitely it's 90-degree angle, so it's a right angle triangle, and tangent theta, it's what? It's r over h at any moment of time, but it's also 4 over 12. Or it's the same as if you consider similar triangles and write ratio. And hence we can see that what? R is 1/3 h. Hence volume becomes 1/3 pi radius squared, so 1 over 9/8 squared, and h, so it's what? Pi over 27 h cubed. And now we volume depends on h only, and we can differentiate with time both sides, so dv over dt becomes what? Pi over 27, and h is some function of t, so we apply chain rule, and it says that it becomes 3h squared dh over dt. When h is 6, so we need dh over dt, and it's what? dv over dt. Let's rewrite it's dv over dt, or we can substitute and then get dh over dt. So dv over dt, it's what? It's 10, it's pi over 27, and actually we can simplify, divide by 3, so it's pi over 9. H squared, what is h? When h is 6, so it's 6 squared, and dh over dt. And we need this dh over dt. Dh over dt is equal to what? And we can see that we can simplify. It's just 4. It's 5, 2. So it's what? 5 divided by 2 pi. And meters per minute, or what? Yes, minutes, so meter per minute. And that's all for this question.